All right, so I want us to look at our 4.2 notes, what we were working on yesterday, and I just want to finish up the second example right here. So take that out, and I want you to take out a graphing calculator as well, because we're going to be using that. And feel free to pause this video whenever we need to if we're kind of getting a little bit behind or anything like that. So the first thing I want you to do is we're going to take this function right here and we're going to put it into my y equals. So you're going to type that whole thing into the y equals. Okay, and you should know how to do that. So we're going to plug that in. I'm going to let you do that. And once you get that in, what we want to do in these types of problems is be able to look at the table of values specifically and try to analyze some of the changes, patterns, and characteristics of the graph without simply just clicking on graph and just seeing it. Okay, we want to look at the table of values and try to figure out some of these things. So we're going to click on second and graph now. So we're going to hit second table and we're going to see the table of values there. Okay, so you should be able to kind of see, you know, as we scroll on the x's, if we go far negative, you can see that the y values are just going to negative infinity. You can kind of see the ends of that. And we can go around here. If I go to x's that are bigger, like past, you know, looks like 3, 4, 5, and as x increases here, you can see the y just goes to positive infinity. And so we can see the end behavior. In the middle here is where some stuff is changing. And so this is kind of where I want to look at and analyze. So what I'm going to do is I'm just going to copy this x and y chart to the side. You guys can look at your calculator or you can just follow along on the screen too. And we're going to answer these questions. So the first part of this section says determine the consecutive integer values of x between which each real zero is located. We're trying to locate the zeros of the graph. We're trying to say when is the y value 0? And if you look at the table, so let's say this is our x and this is our y, we're trying to locate the 0. So this is part A. We can see that we kind of got lucky here. Here's one of the zeros right here. X equals 2 gives us a 0. So that's exact. We can just say, look, x equals 2. That's one of our zeros. And I'm going to plot that on my graph because we know that just by looking at this table. At x equals 2, we have a 0. Now, the other thing we want to do is try to estimate where the other ones are just by looking at the graph. So what we look for is in the y values, we look for changes in the signs. We look for when does it go from negative to positive or vice versa. So if we look at that, we can say right here, right, the y value is -5 and then it goes positive. So what is that 0? Well, we don't know exactly, but we do know that the x value is in between these two integer values, -3 and 2. So I'm going to say for part A, there's another 0 approximately. I always put that approximation symbol because we don't know. Or, you know what, we can just put, we can just write out in between -3 and -2. There's a 0 in between there, -3 and -2. So that's another one. Now I'm going to plot that on my graph as well. So in between x equals -2 and -3, that's about right here. I'm just going to guess. About -2.5. And then we continue looking here and see that there is another change right here we go from positive to negative again. So these two values in between -1, -1 and 0, there's another one, right? Because the sign changes. We're going from y is positive to y is negative, and it just makes sense that if I'm positive on a number line and then I travel to the negatives, I'm going to be passing by 0, and there's going to be a 0. So there is going to be one in between -1 and 0. So -1 and 0. So I'm just going to guess about -0.5. There's going to be another 0 right there. So the first skill that you should be able to do is look at a table of values and tell me about where the zeros are just by looking at it. Okay, so that's part A. We have the zeros about. Now part B says estimate the coordinates of any extreme values. So that's going to be any high points or any low points, any relative maximums, relative minimums. So how do we find those? So now we're going to look at more patterns of the y values, specifically where the y value is changing from increasing to decreasing. Again, think about the idea of the roller coaster, right? We talked about that kind of model. And as we're going kind of up and down these, this graph, whatever it looks like, when are the y values increasing and then changing to decreasing? Or when is it decreasing and then changing to increasing? Where does that change happen? So if we look at the y values, we want to see these patterns. So we're starting, if we start up here, it's at -152, and as we go down, it's actually increasing. The y values are getting bigger, the y values are getting bigger, -30, -5, 4, it's up to y equals 4, and then after that, it starts going down. It goes back down to 3. So you should be able to look at this and say, right here, there's some sort of critical value there. It looks like that's going to be a maximum value, a relative maximum value, because we have 4 there, and if you look above or below it, the numbers are smaller than it. Okay, so you look for those changes. So I'm going to say right here is a clue to saying this looks like a relative maximum. So for part B, looking at this table, I'm going to say there's a relative maximum at -2,4, approximately at -2,4, because I don't know exactly, but it appears on the table that this is a little peak or a high point. All right, so then we want to continue to look for more of these. So then we look at the y values again. So we're at 4, and now it looks like we're going down, right? So we're going down, we're decreasing, -2, -5, we're getting down to -5, and then after that, it goes back up to 0. So when we're looking at this, this should also pop out at you as being another kind of turning point right there at -5, because we're decreasing to -5, and then the y values jump back up to 0. So if you think about it, we're going down the roller coaster, we're decreasing, and then we're going back up. So that point that we're describing there is going to be like a low point, right? It's going to be like a relative minimum here. So I'm going to describe that point as being a relative min. Okay, so I'm going to say, again, we're just looking for clues here. We're not all exact. We're just kind of looking at this story of the table and just trying to figure out, okay, where are the highs and lows. So the relative minimum, it looks to be at about 1, -5. So I'm going to plot these 2 points because I think they're critical points of the graph where we're changing. So -2, 4, so the point -2, and then 1, 2, 3, 4, like up here, and then 1, -5. So 1, 1, 2, 3, 4, 5 down here looks to be like a low point. And really, all the points on our table, we could just plot every single point that we find and just plot all the way through, and then just connect the dots and do that. We can certainly plot more points, fill in more gaps if we're a little bit unsure. Okay, so we have all these kind of critical points. Now let's finish and kind of sketch the graph. What happens as x gets larger and larger and larger? The y value goes to infinity. So after this little kind of 0 point, I know this graph is going to be going way up. It's going to be increasing. And as x goes further negative at, from this 0, the y values are going to be going down to negative infinity. That's sort of the end behavior that we know already exists from x cubed. And then we try to fill in the gaps. Then we say, all right, well, this green point we think is that little top point. So let's just say we're going up this roller coaster, and we think that's where it changes, and it's going down. It hits the 0 along the way, and we continue down, way down here. It looks like there's another kind of low point here, and then we increase back up. We pass the 0 again, and there we have it. Okay. So the main skills that I want you to be able to do is, if you're given a table, or if you're just looking at the table, trying to figure out, okay, the changes in the table where we can sort of identify where those zeros would be, identify where the maximum and the minimums would be, and also understand the end behavior. So we haven't written the end behavior yet. The end behavior, which we can see from the table, but we should also know from previous sections. This is an x cubed, so I know the end behavior, and the leading coefficient is 1. I know the end behavior is going upright and then down left, just from before, and we can see that with our sketch here. But if we write that out in the notation we've been working with, we would say as x goes to infinity, then f of x also goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. So we should be able to write that, and then D is state the domain and the range. So this is something that we've done over and over again, but the domain for this graph is going to be all real numbers, or negative infinity to positive. And the range looks like we have everything there as well, negative infinity to positive infinity. Okay, so not exactly a problem that's just, follow these 3 steps, just like solve this equation. It's more of an analyzing the function, looking at the table and trying to find clues as to what this function is doing. Okay, that's why I only have a handful of questions on your homework, but I really want you to dig in there and do that, because you're going to have questions like that on the test, and I want you to be able to go through that type of thinking.